For this lecture video, we will be answering problems involving dynamics of motion. So this is the first problem. A dock worker applies a constant horizontal force of 80 newtons to a block of ice on a smooth horizontal floor. The frictional force is negligible because the floor is smooth. The block starts from rest and moves a distance 11 meters in 5 seconds. So what is the mass of the block of ice? And if the worker stops pushing at the end of 5 seconds, how far does the block move in the next 5 seconds? Okay, so these are the given. We are given with a force which is equal to 80 newtons. And then we are also given with the initial velocity. It is said in the problem that the block of ice starts from rest at the initial point. So we have v naught x is equal to 0 at x equals 0 and at time t equals 0. And then after 5 seconds, the distance covered or traveled by the block of ice is equal to 11 meters. Okay, so we have the distance, or this is just equal to x. So since we are considering horizontal motion, so we have distance denoted by x is equal to 11 meters after time t equals 5 seconds. Okay, so the first physical quantity that we will be solving is the mass of the block of ice. Okay, so in order to solve um, this, we need to recall first the important equations that we can use for this problem. So we have F is equal to ma. So since the object is accelerating, then we have this one, Newton's second law of motion, the law of acceleration, F equals ma. And then we can also use the equations that we have learned in kinematics. So we have x equals x naught plus v naught x t plus 1/2 multiplied by ax t squared. Okay, so we will use this to find the acceleration. So we will use this equation to find the acceleration. To find the velocity, we will also use another equation from the kinematics equation. So we have velocity along the x can be obtained using this equation. So we have v sub x equals v naught x plus a sub x times t. Okay, so the following are asked. So we have the mass. We need also to find the acceleration, and then we will find the velocity afterwards. First, in order to find the mass, we need to find first the acceleration using this equation. Okay, so we have x. So using, this is our equation 1, equation 2, and then we have equation 3. Okay, so we will use first equation 2 to find the acceleration. Alright, so we have x equals x naught plus v naught x times time plus 1/2 a sub x t squared. Now we are given with this. So we have at x equals 11, at t equals 5 seconds, you have x equals 11 meters. Okay, so we can substitute our x naught is 0. So this is where the motion started. So we label it as the origin. X naught is equal to 0. And then the initial velocity is also equal to 0. So our equation has been simplified. So we have x equals 1/2 a sub x t squared. Okay, or we have a sub x is equal to 2x divided by t squared. Okay, so substituting, we have 2 multiplied by our x is equal to 11 meters divided by t squared. So you have 5 seconds squared. So we will get this is equal to 0.88 meters per second squared. Okay, so this is the acceleration. Now that we have the acceleration, we can use equation 2. So use equation 1 rather. So use equation 1 to find the mass. So from equation 1, we have F equals ma. Therefore, m is equal to the force divided by the acceleration. Okay, so we have the force, which is equal to 80 newtons, divided by 0.88 meters per second squared. So we have the mass is equal to 90.9 kilogram. Okay, so this is the mass of the block of ice. And then for letter B, we are asked to solve for if the worker stops pushing at the end of 5 seconds, how far does the block move in the next 5 seconds? Okay, so for this problem, in order to determine the distance traveled by the block of ice after the worker stops pushing, we need to find first the velocity of the block of ice within the first 5 seconds. Okay, and then we will use it as the initial velocity after the worker stops pushing it. So since the pushing has been stopped, it means that the object or the block of ice is no longer accelerating in the next 5 seconds. Okay, so it is moving with the same velocity as it has in the first 5 seconds. So, for example, initial position of the block of ice, and then it has traveled 11 meters in the first 5 seconds. So in the first 5 seconds, it has traveled 11 meters according to the problem. And then what is asked here is how far does the block move in the next 5 seconds? Okay, so we will be looking for this distance. So how far does it move after another 5 seconds? Okay, so what we will do is to find the velocity, final velocity. So we will look for its final velocity in the first 5 seconds, and then we will use it as the initial velocity for this motion. So this is part 1 of the motion, and then part 2 of the motion. The final velocity in part 1 will become the constant velocity here in part 2. Okay, since nag-stop naman si worker o push, then it is not accelerating anymore. Remember that the law of acceleration states that a net force causes acceleration. Since there is no force acting on the block of ice after 5 seconds, since the worker stops pushing, then the final velocity in the first 5 seconds will be equal to the velocity, the constant velocity in the next 5 seconds. At the end of the first 5 seconds, the final velocity v sub f is equal to v naught x plus a sub x times time. So this is equal to, your v naught x is equal to 0. So we are left with the acceleration times time. So 0.88 meters per second squared multiplied by 5 seconds. Okay, so this is equal to 4.4 meters per second. So this is the final velocity. And again, this velocity is the constant velocity of the block of ice within the next 5 seconds. Alright, so let us write V is constant, and it is equal to 4.4 meters per second in the next 5 seconds. Therefore, the force is 0, the acceleration is equal to 0 since the object since the worker stops pushing, then there will be zero acceleration. Okay, so we have x equals x naught plus v naught x times time plus 1 half axt squared. So the same equation that we used in letter A. Now this time, this is equal to 0 because a sub x equals 0, x naught is equal to 0. So we have x is equal to, your v naught x here is equal to v sub f. Okay, so you have 4.4 meters per second multiplied by 5 seconds. Alright, so this is equal to 22 meters. So in the next 5 seconds, the block of ice, although the duct worker stops pushing, it has traveled 22 meters.